Welcome back to another video, and in this video I'm going to teach you what you have never been taught in physics. I guarantee you that 100%. Let's get into it. This formula is well known to a lot of people in the physics arena. Now it might shock you, but a lot of people, including physicists, do not know what this means. They mostly know what this means. Now this and this are two different things. Now you might be familiar with Newton's second law, where we have F is equal to ma, like neglecting relativistic effects, where we have F is equal to ma. Now a lot of people say F is the cause and ma is the effect. Now the same thing applies in this case. W is more of a cause, but I'll also refer to it as a source. It's a cause or a source. F times D is an effect. F times D is something else. W is something else. The same way F in Newton's second law is something else, whilst Ma is something else. Now, W is what you commonly refer to as the energy, but in this video we shall refer to it as a measure of strength. So W, I'm beginning to define the terms of the formula now. W on the left side of the equation, what we're calling the source or the cause, this is a measure of strength. On the other hand, F times D, this as a whole, not D individually, not F individually, this as a whole. Now, do not be intimidated by the arrows and this fancy dot. For now, these do not mean a thing. Just assume that this is a simple multiplication, a simple scalar multiplication, F times D. Now, this as a whole has a meaning. I'll repeat, this as a whole has a meaning, but that meaning is entirely different from what's on the left-hand side. F times D, pay close attention. This is it. This is the number one thing a lot of people do not know, and what you were never taught in high school, what you were never taught in college, and what you might never be taught actually. F times D is the total quantity of force. I'll repeat that. F times D is the total quantity of force. Total quantity of force for what? Of what? From where? Now I mentioned that W is a measure of strength, but what strength? Let me explain. Say you want to push an object. Let me give an illustration here. Say you have an object, and say we've got a frictionless surface. I'm making the surface frictionless so we avoid all complicated details. I know there are a lot of people who will be like, oh, you forgot friction and blah, blah, blah. So we just want to keep the details to a minimum. Say this is a body, and we exert a force F on the body. In order to move this, we have to possess a certain amount of strength. Like in order to move this object for a certain amount of distance, we have to possess a certain amount of strength, or a certain amount of strength will be taken, or a certain amount of energy will be taken from us in order to move this body. When we move this body from point A to point B, a certain amount of energy has been taken away from us, or a certain amount of strength is required to move the body from A to B. This is what I'm referring to as W. This is what you are told is work done while you're in school. This is what teachers commonly refer to as work done. But F times D, like I mentioned, the total quantity of force is something else. It's an effect. It's an effect brought about due to the presence of energy, due to the presence of strength in us, or in whatever is responsible for doing the work. Now, how do we visualize this? How do we bring it to an intuitive sense? Say this is the distance D. Say this is the distance D. We want to move our object or our body. Keep in mind that there are a lot of points in this path through which we have to traverse or pass through. Now, whilst we are moving the body from A to B, maintaining a constant force, like in this case, I'll assume constant force. While we're moving the body from A to B, maintaining a constant force, what happens is during the passage of each point in space, we are still exerting our force F up until we reach point B. Now notice this. We have a certain number of forces in this line of length, and we can count these. Say we've got 25 of these forces, which would mean we've got 25 points. If we have 25 of these forces along this length, it means we've got 25 points in this length. That is 25 units of smallest units of length make up this entire length. And if that is the case, then it means our force of F has been exerted 25 times during this entire course. I'll repeat. It then means if we've got 25 forces, or we've got 25 points in this entire length, what it then means is if we maintain the constant force of F while pushing our body, and it passed through this point and this point and this point, and we've got a total of 25 points, what it then means is the total amount of force we have exerted is F plus F plus F plus F plus F plus F plus F up until we reach the F at the very last point here at B. And in this case, it's 25. So from point A to point B, we have exerted a total quantity of forces of 25. So that is 25F. And in this case, say F is equal to, say, 10 newtons. If F was 10 newtons, then we would have 25 times 10. Remember, this is just multiplication. 25 times 10, which is equals to 250. What is 250? 250 is the total quantity of force. Remember, here we just said F. We did not give the value. Now we have provided the value, so it lends us to this. It gives us this. So this is the total quantity of force required to move us from point A to point B. Like I said, this indicates the total quantity of force. So I hope you now have a better understanding. This represents the total quantity of force required to move from a certain point A to another point B, or to a certain point B. And this represents the strength required to do that. So in other words, for a certain quantity of force, there is an associated strength that is required to produce that force. So in this case of 250, there is a certain quantity of strength that produces this quantity of force of 250 newtons. But like we do with Newton's second law, where F is equal to ma, where ma is an effect and F is a cause, we can simply use this as a measure of the cause. So whilst we say 250 represents the quantity of force that was required to move from point A to point B, we can also use this very same number to be a measure, because it's proportional to the strength. We can also use it to be a measure of the strength that was required to produce this quantity of force. So in this case, we would have what would be the strength required to move from A to B? The strength required to move from A to B would be 250 joules. What would be the total quantity of force required to move from A to B? The total quantity of force required to move from A to B would be 250 what? Newton meters. But we still use the same units. This unit and this unit are the same because we have made this 1:1. Now if we introduce a certain constant here, we can do that. We can introduce a certain constant here, say k, so that we do not have I would say a case where the values are always equal. That is, when we have a strength of 250, we have a total quantity of force of 250. If you want to make the values unequal, you can just introduce a constant so that the magnitudes on this side are always different and are never equal. Like that is the magnitudes of this quantity, which we're calling the total quantity of force. I'll write it here. Total quantity of force. So this is the total quantity of force, and this is the measure of strength, or what you call energy. So this is the energy, and this as a whole is the quantity of force. So in order to produce any motion, number one, we need to possess energy. Now when we possess energy and push a certain body or produce any kind of motion, we will be exerting a force during that push. Now the total quantity of force that would be required to move from A to B is what's defined by F times D, and is proportional to the energy we possess, or proportional to the energy that's responsible for producing this quantity of force.